So what if I told you that the most valuable focus group you will ever run for your next product launch contains exactly 0 human beings?
I mean, it sounds crazy, right?
It really does. But think about your current workflow right now. You have this brilliant idea on a whiteboard,
Right.
but you have like basically no customer data,
Right.
and you have a fraction of the budget you actually need. Plus, your entire target audience is currently, living inside a server rack as billions of parameters in a neural network.
Yeah, which is a wild concept.
Exactly. So are you really going to burn months of runway scrounging together physical surveys and paying for focus groups that just tell you what you want to hear? Or do you leverage the architecture we already have to simulate human decision-making at light speed?
Well, that is basically the ultimate question facing every product and engineering team right now. Operating in a data vacuum used to be, well, it was the default state of early stage development.
Yeah, just guessing, essentially.
Totally. We relied on gut feeling, boardroom brainstorming, and honestly, an unhealthy dose of confirmation bias.
Oh, massive confirmation bias.
Right. But the shift we are seeing, the shift we are dissecting today, is moving from that qualitative guesswork to deterministic simulation.
So, welcome to this deep dive. If you are listening to this, you are not here for surface-level tech trends. You are building systems.
Yep, you're the real practitioners.
Exactly. You live and breathe applied AI, and you want to know how to fundamentally rewire the way your team tests and deploys products. Today's mission is to deconstruct a highly practical, implementation-ready framework.
And this is from a fascinating 2026 paper by Debabrata Pruseth, right?
Yeah, Debabrata Pruseth. He's an applied AI leader and technology strategist. And the paper is titled Building a Persona-Driven Survey Engine, Using AI for Synthetic User Modeling and Decision Simulation.
It's quite a title, but Pruseth's framework is really a masterclass in applied data science. He isn't just theorizing about the future of AI here.
Right, it's not just theory.
Exactly. He outlines a really rigorous 4-layer architecture and a 10-step pipeline for creating what he terms a synthetic focus group.
A synthetic focus group. I love that term.
It's great. It basically involves taking foundational diagraphic data sets, piping them through constrained large language models,
Yeah.
and mathematically simulating how specific market segments will react to a product.
And doing all of that before a single line of application code is ever written, which is just huge.
Oh, absolutely huge for cost savings.
Let's attack the core problem first because, well, traditional market research is totally broken. If you are running user tests right now, you know the friction.
Recruiting is a complete nightmare.
It is. Scheduling one-on-one interviews takes weeks. Synthesizing the unstructured data from those interviews takes even longer.
Yeah, and it is prohibitively expensive. It
Mhm.
just does not scale.
No, not at all. And ironically, to get good data, you often need an existing user base to poll in the first place.
Right. And when teams lack that existing base, they default to assumptions. They build user personas based on, like, marketing stereotypes.
Which is so dangerous.
It is. Building a minimum viable product on untested assumptions is financial suicide, particularly in high-stakes domains.
Right, like finance or healthcare.
Exactly. If you are building a fintech application or a healthcare portal or an enterprise security tool, you really cannot afford an MVP that misreads the user's risk tolerance.
Because the failure state isn't just, low retention, it is a catastrophic loss of capital.
Precisely.
But I have to throw a massive red flag on the play right here, though. When I first saw Pruseth use the term synthetic focus group, my immediate reaction was, well, aren't synthetic users just fake users?
Right. That's the natural pushback.
Yeah. Like, if we base critical architectural and business decisions on imaginary people generated by a transformer model, aren't we just building a highly sophisticated echo chamber?
That is the defining skepticism of this entire field, honestly, and it is a necessary hurdle. But Pruseth addresses this head-on by reframing the utility of the system. He explicitly states that synthetic personas are not replacements for human validation. He calls them decision accelerators.
Decision accelerators. Okay, that shifts the burden of proof a bit.
Yeah, what's fascinating here is that it implies the AI isn't there to give you the unassailable ground truth answer.
Right, it's not an oracle.
Exactly. It is there to help you iterate through your terrible ideas computationally, so you only spend your actual research budget on the highly probable good ideas.
Okay, that makes a lot of sense.
Okay.
So let's look at what simulating decision psychology actually means at the model architecture level.
Yeah, because we are not asking an image generator to just spit out a fictional face.
Right, and we're not using zero-shot prompting to ask an LLM to write a creative backstory about a fake guy named Bob.
No, we are taking grounded, empirically verified demographic data.
So we are loading that data into a constrained vector space, right?
Mm.
And forcing the model to reason through a strict set of parameters.
Exactly. We are mapping the mathematical contours of human decision-making. The model is predicting the most statistically probable reaction to a set of variables based on its training distribution.
To really ground the mechanics of this, we cannot just talk in abstracts. We need to look at the practical case study Pruseth used to stress test his engine.
Yeah, the FlexiSave Kids plan.
Right. He didn't build this pipeline to test some simple to-do list app. He introduced this test product, the FlexiSave Kids plan. He defines it as a hybrid savings and micro-investment tool designed specifically for parents of children aged 4 to 10.
The selection of that specific product category is brilliant, honestly, because it maximizes the difficulty level of the simulation.
Bit of the emotional weight.
Exactly. A kid's financial product carries an enormous emotional and psychological payload. You're asking a parent to hand over their money,
Right.
and simultaneously you are asking them to trust a digital institution with the future financial security of their child. The trust parameters required for conversion are just incredibly complex.
It is the ultimate stress test. I mean, if I am building a food delivery app, the variables are basically binary. Is the user hungry? Is the delivery fee under $3?
Yeah, the latency in decision-making is minimal there.
Exactly. But investing for a 6-year-old, the friction is massive. You have anxiety, you have regulatory concerns, you have the complexity of compound interest modeling.
So if the persona-driven survey engine can successfully navigate that emotional minefield of parental financial anxiety, it proves the architecture can handle almost any enterprise or consumer product.
It has to prove it can detect deep-seated, nuanced concerns about data security and market volatility.
Great. It must separate a parent struggling with monthly cash flow from a parent looking to optimize tax-advantaged growth. If it just outputs generic platitudes about saving for the future, the model fails.
I look at this framework like a physics engine in a flight simulator for product managers.
Oh, that's a good way to put it.
Right. Like when you train a pilot, you put them in the simulator, and you introduce extreme weather variables, mechanical failures, catastrophic scenarios.
You want them to crash the digital plane 1,000 times?
Exactly. You kill the weak concepts early in the simulation before you ever put real passengers or, real venture capital on the line. Pruseth's framework is basically the physics engine for user behavior.
That analogy holds up technically, too. I mean, a flight simulator is totally useless without highly accurate topographical and aerodynamic data.
Right. If the data is bad, the simulation is bad.
Exactly. So our synthetic survey engine is utterly useless without highly accurate structured human data, which brings us to the actual architecture of the framework.
Okay, let's get into the layers.
So Pruseth breaks this down into 4 distinct layers, executing across a 10-step pipeline. Let's dig into layer 1, the persona extraction layer, which encompasses steps 1 through 4.
Step 1 is loading the data set. And this is really where we separate the serious practitioners from the prompt kiddies.
Oh, absolutely.
Pruseth does not just open a chat window and type, hey, generate 100 parents. He starts with a massive, pre-existing structured data set.
Specifically, he cites NVIDIA's Nemotron Personas USA.
Right. This is a corpus of over 1 million personas based on real, verifiable United States demographics.
The foundational layer must be anchored in statistical reality. You ingest this massive array, which likely contains categorical demographics, continuous variables like income, and unstructured free text attributes describing behavioral habits.
But raw data sets at this scale are incredibly noisy. Right?
Very noisy. So step 2 is cleaning and preparing the data. And this isn't just formatting, it involves computationally heavy lifting.
Like what kind of lifting?
Well, you have to handle null values, like do you impute missing income data or do you just drop the record entirely? And you have to normalize the text fields.
Let's pause there because token economics really matter here. If you have 1 million records with unstructured text, you cannot just feed that raw JSON into an LLM context window.
Oh no, it would break the model and bankrupt the team in API costs.
So mathematically, how do we clean this up so the system can actually process it efficiently?
You utilize embedding models. You take those disparate text fields, hobbies, job descriptions, recent purchases, and you run them through an embedding model to convert the semantic meaning of that text into dense, multidimensional vectors.
Okay, so you create a unified mathematical representation of each person's life.
Exactly. A representation that a machine can instantly search and filter without having to read a single English word.
which sets up the computational challenge of step 3, identifying the target audience. In the Flex2Save case study, we're looking for parents of kids aged 4 to 10.
Right.
Now, if the NVIDIA dataset has a clean Boolean column labeled haschild age 4 to 10 set to true or false, this is just a simple SQL query.
But real-world data is rarely that clean.
Exactly. So Pruseth mentions using proxy signals to find the audience. Walk me through the actual data science of a proxy signal here. Like, if the data set doesn't explicitly have a checkbox that says parent of a 6-year-old, how exactly do proxy signals work in step 3?
This is where semantic distance and vector databases become totally critical. Let's assume the data set lacks an explicit number of children column.
Okay.
However, it contains the vectorized embeddings of these individuals' media consumption, their transactional history, and their weekend activities. We generate an ideal target embedding.
So a mathematical representation of the concept parent of a young child.
Exactly.
So you embed keywords like pediatrician or minivan safety ratings, youth soccer cleats, and maybe elementary school district.
Yes. You then measure the cosine similarity between your target embedding and the million records in your database. The system scans the latent space.
Looking for matches.
Right. If a persona's vector sits very close to your target vector, maybe because their raw text mentioned buying children's vitamins and watching animated movies on streaming services, the model flags that semantic proximity as a strong proxy signal.
But wait, mathematically, how do you prevent the model from misinterpreting the signal?
What do you mean?
Like, what if the persona buys children's vitamins because they're a pediatrician, not a parent? Or what if they buy toys because they're a doting uncle? If we rely purely on semantic proximity, aren't we introducing a massive amount of noise into our foundational sample?
That is the exact vulnerability step 4 is designed to solve. Scoring and filtering.
Yeah.
You do not rely on a single isolated proximity score. You build a weighted scoring matrix. Buying a toy is a low-weight signal. It might contribute 0.1 to the overall confidence score.
Right.
But a pattern of researching elementary school zoning, combined with frequent purchases of bulk pediatric supplies and a search history related to child tax credits, those combined variables carry a massive weight.
So you set a strict threshold.
Yes. The engine scores all 1 million profiles and ruthlessly filters out the noise, dropping anyone below, say, a 95% confidence interval. You isolate a refined pool of your exact target audience.
Okay, so at the end of layer 1, the pipeline has ingested 1 million unstructured lives, vectorized them, calculated their semantic distance to our target demographic, applied a weighted threshold, and spat out a high-confidence list of, let's say, 5,000 parents of young children.
Which is phenomenal data engineering.
It really is. But as Pruseth points out, a list of 5,000 parents is not a focus group. It is just a demographic bucket.
Exactly. It tells us who they are, but it tells us absolutely nothing about how they make decisions.
Which forces us right into layer 2, the segmentation layer.
Step 5 is the linchpin of the entire framework. If we connect this to the bigger picture, this is where data transforms into decision psychology.
Because a massive bucket of parents is basically useless for product development.
Totally. Pruseth outlines 6 distinct behavioral segments for the Flex2Save Kids app, and analyzing these segments reveals how the framework actually works.
I want to read through the 6 segments he defined, because they really highlight the required granularity.
Go for it.
First, you have the security-first parent. This vector represents high-risk aversion. They want FDIC insurance. They probably check the app daily in a panic.
Yep, very common.
Second, the growth-oriented parent. This is the investment-focused user. They want aggressive ETF allocations and compound interest calculators.
Right.
Third, the busy, convenience-driven parent. They don't want to see the charts. They want a one-click automated sweep from their checking account so they can just forget about it.
Then you have the 4th segment, the budget-conscious parent. This is a highly sensitive cluster. Monthly maintenance fees or high minimum balances will trigger an immediate churn event.
Oh, absolutely. Fifth is the values-driven or education-focused parent. They view the app not just as a vault, but as a pedagogical tool to teach their child financial literacy.
And finally, the 6th segment, the skeptical parent.
The tough crowd.
Oh, yeah. This cluster exhibits historically low trust in financial institutions. They read the terms of service, they assume their data is being sold, and they look for hidden withdrawal penalties.
If you are building the product roadmap, this segmentation is your reality check. Pruseth asserts a crucial rule here. Personas without segmentation are just descriptions.
That is such an important distinction.
Right. If the output of layer 1 is a 34-year-old mother of 2 in Ohio earning $80,000 a year, That is just a description. It tells you nothing about the architecture of your app.
Exactly, but knowing if she belongs to the skeptical cluster or the busy convenience-driven cluster dictates whether your onboarding flow needs a 10-page security white paper or a single-click Apple Pay integration.
To extend your earlier analogy about casting a movie, if Layer 1 is scanning the entire Screen Actors Guild database to find people of the right age, and look, Layer 2 is defining the specific character roles in the script.
That's a perfect way to look at it. You need the anxious character, the ambitious character, the cynical character.
Because if you run your script only past 10 highly aggressive, growth-oriented actors, you will build a product that fundamentally alienates the vast majority of the real-world market.
You must map the complete cognitive diversity of the user base.
So with the 6 character roles defined, and thousands of potential candidates sorted into those buckets, we have to actually select the actors who will step onto the set.
Right, which enters us into Layer 3, persona construction. This covers Step 6 and 7.
Step 6 is building the persona panel. Pruzith dictates selecting a balanced, diverse set of 10 to 12 personas, pulling representatives from all 6 segments, ensuring no duplicates, and prioritizing the highest confidence scores from Step 4. But this is where I have a major architectural disagreement.
Oh, really? Let's hear it.
Well, compute is cheap. API calls cost fractions of a cent. If we have a high-confidence segmented pool of 5,000 parents, why on earth are we arbitrarily limiting the synthetic panel to 12 individuals?
That's a fair question.
Why not spin up 1,000 parallel instances and get massive, statistically significant quantitative data? Why mimic the limitations of physical human research?
It is a really common misconception that more compute equals more insight in qualitative modeling.
So why do we limit it to 12?
We limit it to 12 because of the mathematics of information gain and the concept of qualitative saturation. When you run deep conversational simulations using LLMs, you are generating massive amounts of unstructured token output.
Right.
If you simulate 1,000 personas, you are paying for an ocean of redundant data. The model will essentially repeat the exact same objections for the skeptical parent 150 times.
So you basically hit a steep diminishing return on token expenditure.
Exactly. In human-centered design research, studies have mathematically proven that after conducting deep interviews with roughly 10 to 12 carefully stratified individuals, you capture over 90% of the core usability issues and behavioral triggers.
Oh, wow. So you don't even need the extra numbers.
Right. Every interview after the 12th provides minimal marginal utility. By restricting the panel to 12 highly optimized, strongly segmented vectors, you maximize signal and eliminate expensive computational noise.
Okay, that makes architectural sense. We optimize for high-density qualitative signal rather than, shallow quantitative volume.
Exactly. Which takes us to the most technically fascinating part of the framework, Step 7, generating clean personas.
We have our 12 raw data profiles. Now we use the LLM to structure them.
Yes. We pipe the raw JSON attributes into the model to generate a cohesive, research-grade persona profile. We define their specific financial mindset, their core goals, their daily pain points, their specific purchase triggers, and their likely objections.
Here's where it gets really interesting, though, because Pruzith puts some serious guardrails on the LLM here. He emphasizes a rigid mandate. Do not hallucinate facts. Keep grounded in the data.
Right. You are not asking the LLM to be a novelist. You are establishing strict bounding boxes around its predictive capabilities.
But how do you mathematically stop a generative model from generating?
It's tricky.
Right. If the base model is GPT-4 or Claude, its natural inclination is to interpolate missing information to create a pleasing narrative.
Yeah, they want to tell a story.
If our NVIDIA dataset says this persona is a budget-conscious teacher in rural Texas, how do you prevent the model from suddenly deciding she has a secret passion for cryptocurrency day trading just because the base model associates finance with crypto?
You control this through parameter tuning and strict schema enforcement. First, you drop the temperature setting of the LLM to near zero, making its outputs highly deterministic.
Okay, so less randomness.
Second, you utilize few-shot prompting combined with rigid JSON output schemas. The freedom prompt looks something like, "You are a deterministic mapping engine." Your sole function is to map the provided input data to the exact required schema fields.
And nothing else.
Right. Extract only explicitly stated or directly correlative facts. Do not interpolate backstory. If an attribute cannot be definitively inferred from the input, output, and LO.
You essentially lobotomize its creativity to enforce empirical rigor. You force a model to look only at the demographic row and extrapolate only the logical, statistically probable financial mindset based strictly on those constraints.
Precisely. By locking down the context window and enforcing zero hallucination policies, you construct 12 highly detailed, rigidly segmented, data-grounded synthetic parents. They are fully formed cognitive profiles, sitting in memory, waiting to be queried.
Which brings us to the operational powerhouse of the entire system, Layer 4, the survey and simulation layer.
That's 8, 9, and 10.
Right. We have the actors on the set, fully in character. Step 8 is generating questions. The LLM evaluates the product spec for the FlexiSave app and generates highly targeted questions designed to probe decision triggers, objections, and trust thresholds.
And these are compiled into a master survey.
Then, in Step 9, the simulation executes. The 12 personas are fed the survey and prompted to answer it.
And the architecture of the response prompt is vital here. We do not want simple Boolean outputs.
Right, no simple yes or no.
We do not ask them to rate the app from 1 to 5. The system prompts the personas to explain their reasoning in natural language, acting strictly within the constraints of their assigned persona vectors. We want paragraph-length explanations of their friction points.
I am going to challenge the core integrity of this entire process on behalf of the listener, though.
Bring it on.
This is where the framework risks sounding like digital navel-gazing. If an LLM generates the survey questions, and then the exact same LLM architecture turns around and answers its own survey, how is that anything other than a closed loop?
It's a common fear.
Isn't the model just self-confirming its own latent biases? It's just a machine talking to itself in a vacuum?
If you execute it poorly, yes, it becomes an echo chamber. The key to preventing self-confirmation bias lies in strict parameter compartmentalization. You are not asking a single monolithic instance of an LLM to have a conversation with itself.
Oh, okay. So what are you doing?
You are spinning up isolated parallel execution environments.
Break that down. How are the environments isolated?
In Step 8, the generator model operates in an objective analytical state. Its prompt directive is essentially adversarial. Find the structural weaknesses in this product spec.
Okay, so it's playing defense.
Exactly. In Step 9, the respondent model operates under a completely different set of weights and constraints. When you load the skeptical parent persona into the context window, you fundamentally alter the model's predictive pathways. You restrict its latent space to favor concepts of anxiety, distrust, and scrutiny.
So it's like adjusting the sliders on an audio mixing board. For the skeptical parent, you push the distrust slider to maximum and pull the convenience slider to 0.
That's a great visual.
When that specific instance of the model reads a question about linking a bank account via Plaid, the parameters mathematically force it to output text related to data encryption, API vulnerabilities, and withdrawal lockup periods.
Exactly. And simultaneously, in a completely separate compute thread, you load the busy convenience-driven parent persona.
So the sliders are reversed.
Yes. That instance of the model reads the exact same question about bank linking, but its constrained parameters prioritize speed and automation. Its output will focus on the seamlessness of the integration and frustration with any multi-factor authentication steps.
So the LLM is not talking to itself.
No, the architecture is running parallel simulations of distinct, divergent human psychologies colliding with the same product variables.
The friction between those parallel simulations leads directly to Step 10, extracting insights.
The best part.
The system aggregates these 12 rich, divergent, highly opinionated responses. It runs a differential analysis to identify recurring needs, locate fatal pain points across segments, and map the product's positioning strategy.
And it does this in minutes before you have authorized a single sprint for your engineering team.
Step 10 is where Pruseth delivers the most profound realization of the entire paper, I think. He establishes the golden rule of synthetic simulation. The biggest insight comes from differences between personas, not averages.
Yes. This is where traditional, shallow quantitative data fails engineering teams every single day.
Because if you design for the statistical average, you design for nobody.
Precisely. Let's look at the math of it. If you take the security-first parent who demands absolute zero risk, treasury-backed yields, and a physical customer service number, and you average their needs with the growth-oriented parent who wants maximum equity exposure and algorithmic rebalancing, what do you get? You get a mathematically average product that is far too risky to satisfy the anxious parent and far too conservative to interest the ambitious parent. By chasing the average, your product fails to convert either segment.
The aggregate is a trap. The true value of the synthetic focus group is identifying the tension points. Your job as a product architect isn't to build a middle-of-the-road app. Your job is to figure out how to bridge the delta between the skeptical parent and the busy parent.
Exactly.
How do you engineer the UI so it feels impenetrable and highly secure, while simultaneously requiring only 2 taps to execute a deposit? That tension is where the market alpha lives.
And that is the exact output of this engine. It provides the architectural blueprint for resolving those opposing constraints. However, as practitioners, we must subject this entire framework to a rigorous reality check.
Yeah, because a zero-cost simulation machine that hands you a perfect product roadmap sounds like utopian vaporware.
Right, we have to examine the hard technical limitations that Pruseth himself outlines to ensure this tool isn't misused.
Let's do the autopsy on the limitations. The first limitation is foundational. These personas are inferred simulations. They are not physical users interacting with a compiled codebase in the real world.
Correct. The engine simulates cognitive intent, not physical interaction. It can tell you that a user will want to click a button, but it cannot tell you that the button's hitbox is too small for a human thumb on a cracked mobile screen.
That makes sense. The second limitation is the most technically perilous, and it revolves entirely around data quality.
This raises an important question regarding AI governance, which really ties back to Pruseth's broader expertise.
Right. The outputs of this engine are utterly subservient to the training distribution of the initial dataset and the baseline weights of the LLM.
This is the critical point of failure for any team attempting to deploy this pipeline. If we utilize the Nemotron personas dataset or any foundational demographic corpus, we must mathematically audit its distribution.
So, if the dataset's historical collection methods resulted in a skewed distribution, say, it heavily over-indexes on urban, high-income coastal demographics and under-indexes on rural cash-based economies, your simulation is fundamentally compromised.
Exactly. If the underlying vector space lacks density in certain demographics, your synthetic focus group will confidently output mathematically flawed assumptions. You will architect an application optimized for a phantom market.
That is terrifying.
It is. Furthermore, you have to account for the baseline drift of the LLM itself. Even with zero temperature settings and strict JSON constraints, the foundational model retains the statistical weighting of its training data.
Give me an example of how that breaks things.
Well, if the model's training data predominantly associates the phrase budget conscious with coupon clipping, it may struggle to accurately simulate a high net worth individual who is simply fee-averse regarding asset management.
Oh, I see.
You must ruthlessly audit your embeddings to ensure the model isn't relying on statistical stereotypes to fill context gaps.
Which makes Pruseth's final non-negotiable limitation the most important takeaway of this deep dive. This pipeline must always be followed by and calibrated against real human validation.
Absolutely. The framework does not exist to replace human beings. It exists to replace the early-stage, high-burn-rate guessing game.
It prevents your engineering team from spending 6 months and $1 million in venture capital building an architecture that fundamentally misunderstands the core user psychology.
It gets you to a highly refined, deeply considered, mathematically probable prototype at light speed. But once that prototype is compiled, you must put the glass screen in the hands of real parents in the real world.
You have to measure the delta between the simulation and reality.
Exactly.
Think about what this means for your next deployment cycle. You aren't taking a raw, untested concept to your alpha testers and asking them basic functionality questions. You are taking a highly evolved product and testing incredibly nuanced behavioral hypotheses that the AI generated.
You are validating the edge cases. It is a massive force multiplier for any team.
It fundamentally changes the velocity of product strategy. So, to summarize the immense operational value of this architecture for everyone listening, by deploying Dibra Pruseth's framework, by systematically ingesting raw demographic data, vectorizing it to identify targets, mapping behavioral segmentations, strictly constraining LLMs to construct research-grade personas, and running isolated parallel simulations, your team can iterate relentlessly.
You can mathematically probe, will this architecture convert? For which specific cohort, and what are the precise friction points?
And you do all of this while your idea is still just marker ink on the whiteboard.
You terminate the bad concepts purely through computational cost, completely avoiding the financial sunk costs and technical debt that destroy early-stage projects.
In his conclusion, Pruseth offers a powerful reframing of the industry standard. For decades, the entire discipline of product research has been obsessed with a single flawed question: what do users want? But with this architecture, we realize that users rarely know what they want. Instead, we can elevate the inquiry. We can now compute. How will distinct cognitive profiles think, evaluate, and respond under specific constraints.
And if we extrapolate the mechanics of that final thought, there is a fascinating, almost aggressive application of this architecture that we have to consider.
Okay, I'm listening.
If you can use this exact 10-step pipeline to ingest demographic data and simulate a highly accurate user focus group, there is absolutely nothing stopping your team from repointing the data ingestion layer and building a synthetic competitor focus group.
Wait, stop. That is incredible.
Think about the data vectors available to you. You can scrape and ingest the public statements, earnings call transcripts, engineering blogs, and product release histories of your biggest competitors.
Oh, wow. You vectorize the corporate psychology of their CEO
Yep.
and their lead product architects.
Right. You run layer 2 segmentation on their operational tendencies.
You build a constrained LLM persona of your rival's C-suite. And then, in layer 4, you feed them your upcoming product launch specs and simulate their counter moves.
Exactly. You simulate their marketing rebuttal, their potential pricing drops, their feature parity timelines.
You test your market positioning against a deterministic simulation of your biggest threat. The boundaries of decision simulation are not restricted to consumer behavior at all.
We are looking at the foundational architecture for automated, high-speed strategic wargaming. The companies that master these constrained simulation models won't just understand their users better, they will computationally anticipate their competitors.
That is the exact kind of architectural leverage that changes industries. The whiteboard in the empty boardroom just got exponentially more powerful. Thank you for joining us on this deep dive into Debabrata-Prusitz's synthetic simulation framework. Take these mechanics back to your teams, audit your embedding pipelines, lock down those hallucination boundaries, and keep pushing the absolute limits of applied AI. We will see you next time.